What is good, 7th graders? We are here to do some practice. So let's take a look at what we have. Drag the vertices of the triangle below to draw a right triangle with side lengths of 10, 24, and 26. Okay, if you don't remember, a right triangle has a right angle in it. So it kind of looks like the corner of a square. All right, so we need side lengths of 10, 24, and 26. And in a right triangle, the longest side is the hypotenuse, or the angled side. So let's see if we can make this triangle. We need 10. Let's put 10 on the bottom. We just move these vertices, which is what the points are called, until we get the right numbers. When we make a right angle, the height should be straight up and perpendicular to the base. Perpendicular means that it makes a 90-degree angle, so it looked like the corner of a square. Okay, so we have 22. We need it longer, so we need to go up a little bit. 23, 24, and 26. Okay, you can see when it's a right angle, it puts a little box there. That means that it's 90 degrees. That's exactly what we want. Okay, let's try another one. It says drag the vertices, which are the points, of the triangle below to draw a triangle with 45 degrees, 35, and 100 degrees. Okay, so let's try and get 100 first. 100 is obtuse. So if you don't remember what that is an angle larger than 90. Okay, so that means it will look something like this. That would be an obtuse angle. We need 100 degrees. So we move that down until we get 100. Then we need 45 and 35. We're close. We have 43 and 37. Let's bring this one in a little bit. $39, 38, and 42. $35 and 45 and 100. Perfect. You just got to keep moving those points until you get the angles that you need. Okay? All right, another one here. Drag the vertices of the triangle, the points, to draw a right triangle that is also an isosceles triangle and has two side lengths of 3. Okay, so not only does it have to have a 90-degree angle in it, two of the sides have to be equal length. Okay? And two of the sides have to be 3. All right, so let's think about that. We have 3 on the bottom already. If I move this vertex, I now have 2.5. I have a right angle, so I'm close. I need to make this side longer so that it's 3, just like that one. If I move it up, all right, there we go. We have 3 on the bottom, 3 as the height, and we have a right angle, 90 degrees right there. We met all conditions. X has to be smaller than the other two sides added together. So X has to be less than 4.1 plus 1.3. Remember, according to the theorem, the third side has to be smaller than the other two sides added together. So X has to be less than 5.4. Okay, so that's the high range is 5.4. Then I'm going to look at X and the smaller side. So X and 1.3 is the smaller of the two that we know. So X plus 1.3 has to be greater than 4.1 in order for it to make a triangle. So now I solve for X, get X by itself, just like we did in the previous unit. Subtract 1.3, do the opposite of what we see. X is greater than 2.8. So that's going to be the small range. If X is not greater than 2.8, when we add these two together, it won't be bigger than the third side, so it won't make a triangle. So that's going to be the low range is 2.8. Now I don't even have to look at x and 4.1 because 4.1 is already bigger than 1.3. So no matter what we add to 4.1 for x, it's already bigger than the third side. So we don't even really have to look at that example or that scenario. So using our triangle theorem, these two sides added together has to be longer than the third side. So 8.5 plus 8.0 has to be bigger than x. So 8.5 plus 8.0 is 16.5. So that has to be bigger than x, so that means x has to be less than 16.5. So that would be my number over here, 16.5. Okay, then x has to be greater than, so now I'm going to look at x and the smaller of the two sides. So those two added together, x and 8.0, which is the smaller of the two, has to be greater than the third side, 8.5. Remember, any two sides added together has to be bigger than the third. So now I can solve for x like we did in the previous unit. Subtract 8.0. We get x is greater than 0.5. So that would be my other number, 0.5. Okay? Because x has to be greater than 0.5, otherwise when we add these two together, it won't be bigger than the third. X has to be less than 16.5, because when I add these two together, that has to be bigger than x. So x can't be bigger than the sum of those two. The reason I don't have to look at x and the larger side is because 8.5 is already bigger than 8.0, so x doesn't have to be anything in order for that to be true. It could be 0.01, and those two added together are still going to be bigger than 8.0, because 8.5 is already bigger than 8.0. Alright, let's try another one. Okay, this says order the side lengths of the triangle from shortest to longest. So another cool thing about triangles is the shortest side is always across from the smallest angle. So in this triangle, 48 is the smallest angle. So the side that's across from that is the shortest side. Because if you think about it, the smaller the angle is, that makes a smaller side. The bigger the angle is, makes a longer side. So the smallest side is going to be B. So that would come first. Then the longest side is across from the biggest number, which is 67. So A is the longest, making C in the middle, because it's the middle number. All right, again, the opposite is true as well. So the longer side is across from the biggest angle. So this one we have to order the angles from smallest to largest. So let's find the shortest side, which is 4.8. The angle that is across from that is the smallest angle. So C is the smallest angle. And then 4.9 is the next one in order, and that's across from B. So the next angle would be B. 5.2 is the longest side across from A. So A is the biggest angle. All right, again, side lengths from shortest to smallest. We find the smallest angle across from that is the shortest side. We find the middle angle across from that is the middle length. Biggest angle across from that is the longest side. All right, that's all, folks. Have fun practicing.